Thanks, everybody. And I know that it's early, so I really appreciate that you guys came out at this time of morning after the CTF last night to come and see me talk. So this is really wonderful. Thank you. So AttackDriven Development, more method than anything else. I am losing my voice a little bit, so I'll try not to make it too bad for the people that are going to watch the recording later. But a little bit about me, just kind of to get started. So I am a trust and security engineer at a company called BugCrowd. We offer crowdsourced security solutions for companies to work with researchers, find vulnerabilities, researchers get paid, companies find bugs, everybody wins. It's a really awesome company. We're the party sponsor tonight, so definitely happy to talk more about it in length then as well. Prior to my work at BugCrowd, I worked at a company called Rapid7. So there I was a customer success engineer, and my role was basically know absolutely everything about absolutely all of their products and be able to enable everybody else on those products. So I had to learn a lot about Metasploit, Expose, what have you. And then before that, I was actually an intern at Veracode, where really my passion for web application security became apparent because I knew absolutely nothing about it. They were doing some very cool stuff in it. And I was stuck on the binary static analysis team, so I was doing a lot of Bash and Python scripting, and I really wanted to do web hacking. So that's kind of where that all came about. Also, earlier this year, I launched the InfoSec Mentors project on Pulse Security Weekly, episode 504. You can go back and watch that interview on YouTube if you want. Good, okay. It's also on infosecmentors.net. It's a MVP right now, so it's very lightweight, very simple, but hoping to revamp it in React.js probably early next year. So beyond that, I've been an InfoSec hobbyist for a long time, and I have somewhat humble but simple beginnings, mostly tied around my experiences early on back in the 90s with Diablo, which was Blizzard Entertainment's popular title back on a 233 megahertz PC, 28.8 dial-up. It was really a time to be alive. So with Diablo, I quickly learned in November, shortly after my birthday, they launched Battle.net, and I could now play with my friends online. That was really cool. Especially for me, I grew up in a small town in central New Hampshire, about 5.5 hours south of here, and there was more cows in the town than people. So computers was the only way that I really connected back to the rest of the world. And what I figured out at a very young age was that I could use Telnet, of all things, to connect with Diablo trial accounts to Battle.net without any form of authentication. I could have any username I wanted as long as it was not currently in use on their platform with Telnet. And I was like, this is cool. So what did I do? Well, I did the thing that any juvenile delinquent would do. I wrote a bot in Visual Basic that would connect as many 28.8 dial-up sustaining connections on Telnet to Battle.net, and then I'd spam my friends, I'd spam channels. I was a punk. I was basically just a... So from there, growing up, I learned that, okay, I probably can't be doing this forever because eventually I'm going to get into a lot of trouble for doing this. So I kind of figured that I should maybe start with learning something practical, and software development was where it was at for me. Now that's in VS Code, but prior to that it was Vim or Visual Basic Studio or Visual Basic Editor. And I really wanted to get into web application development, so I used GeoCities, AngelFire, wrote simple websites. And from working at Veracode, I realized that, okay, I don't really understand how websites are built today, and I really don't understand how to use Burp Suite Pro or OWASP Zap or even this Docker thing that people are talking about. I was like, what is this? I've got a virtual machine. Why do I need Docker? And so to that end, it was kind of eye-opening for me that I realized I had a lot to learn, and I'm going to be 32 here shortly, and so I felt like I was behind the 8-ball. I needed to learn quickly, and I needed to learn a lot. So I came up with probably something that a lot of people have done already, and I've just kind of formalized the name for it called AttackDriven Development. And so that process involves a few different things. First of all, it's a sense of purpose. You have to know what you're trying to achieve as a result of the things that you're doing. And so for me, that was very purposefully practicing HTML5 and CSS3 and JavaScript. But as I'm sure many of you have experienced, as you're learning something, something else is being forgotten or being not practiced. And that ultimately is what leads to stagnation or just kind of loss of that ability. And I realized that with all of these new things like the mean stack, so Mongo, Express, Angular, and Node, or even Angular. So AngularJS versus Angular 2 is a monster in and of itself to try and figure out the differences between them, let alone try to learn them. and of course React and Node. And so for me, the process of attack-driven development in a nutshell is very simple. Learn a language or a framework or a library, but learn to build a feature or a simple web page that is purposefully broken. Now, if any of you have ever written like a CTF challenge or a class or a training course and you've had a lab environment, you realize how hard that is. But it also gives you a very deep appreciation for the language and you understand how that works. Now, beyond just learning how to write bad web apps, because let's face it, developers do that all day long anyway, you then take that bad web app and you learn to attack it. So now I'm building a bad web app, and then I'm learning how to use Burp Suite Pro or other tools and methodologies, going out and reading blogs and attacking that web app that I have now built that is broken. But don't stop there. Just because you've written a very simple reflective cross-site scripting does not mean you're a lead hacker. Go back and change the code a little bit, make it a little bit more difficult to attack, maybe accept only certain inputs or a certain length of an input, and make it a little bit harder. Challenge yourself, challenge your friends, and then attack it again. And just work through this process so that you can pick up languages, frameworks, libraries, attack tools, continuous development tools or continuous integration tools, things like Docker, wrap it all up together so that you can be ultimately kind of building a foundation that you can grow upon. And that's attack-driven development as a method in a nutshell. And of course, you don't want to get rusty. You don't want to focus on one thing and then suddenly all these other skills you've built just aren't going to be useful to you. So with that, I do like to talk a little bit about how attack-driven development as a method is different from other methods or practices of development that we see today. The first, of course, is test-driven development. A lot of us have probably heard about it, and if you haven't, it's a pretty simple process of build a test that fails, write some code that then allows the test to pass, and then build another test that fails, and just kind of keep working through this process. And at the end of the day, it's really making sure that as you release features or new code, you're not breaking the existing code that you have today. So having more coverage and having more tests is always good. But of course, it doesn't test for security. And at the end of the day, if your tests are to say you have a lock and you have a door, and the door will still open and close even though you've now added the lock, you're fine. Code works as intended. The feature is good. And at the end of the day, test-driven development doesn't care about security. It doesn't care about making the developers better at their job from a security standpoint. So, of course, attack-driven development can help there because if the developers understand why it is broken, maybe they won't write bad code going forward. Also, back in about 2004, there was a paper called Misuse and Abuse Cases by Gary McGraw and the folks at North Carolina State University, who talked about this whole concept of working with your development team and, of course, your project managers and the business to come together at the beginning of a new project and define what the misuse and abuse cases are. Now, of course, that's over 13 years old. And as a result of that, we're now looking at an agile development process in general, no matter what business you go to. And they're like, no, just meet with all these people and take time to plan this out. And I think as all of us probably realize, that's just not realistic today. And to that end, in addition to that, they say, test it at the end. It's fine. And I'm sure, as we all know and have experienced, that's not fine. Because even if a feature is vulnerable, if the business is relying on that feature being released for a new sale or a renewal, or even just trying to beat the competition to market, that product is going to be shipped, even if it is vulnerable. And at the end of the day, in an agile development world, that's just not good enough. So again, attack-driven development is a great process because if you're testing as you work through the process of developing a new feature or a new code release or a new product, then you've kind of tested it at every stage of development. And again, it's not a problem where you have suddenly a release timeline that you just can't meet because you have to get the testing in at the end. If you've done testing throughout for security purposes, it's really great. And so at the end of the day, attack-driven development is really leaning toward adopting misuse and abuse cases in the process of agile development. So it's all about learning frameworks and languages and features, of exploitation and of building secure web apps, because eventually you'll get to a point where any attack you go ahead and try to develop against that particular piece of code you've written won't work because it's now ironclad. Maybe you're using a whitelist. Maybe you've introduced two-factor authentication. Maybe you've done a number of different things. But at the end of the day, the code that you've now written is secure, and you know bad, mediocre, and good. And you can easily say, okay, if we're using the dangerously set inner HTML flag to true I know that now in React.js, I'm introducing potentially cross-site scripting. Otherwise, React.js is totally fine without having to introduce that flag anywhere. So suddenly, if I know that because I've built some bad features that introduce that and I know how that works and how I can then attack it, I can just simply go look at my code base for that flag and say, okay, can we trace this back to any user inputs? Because if we can, really bad. So again, attack-driven development is really just a continuous testing of misuse and abuse cases and helping to inform both the security engineers, application security developers, and the business about potential downfalls of whatever they're writing in. So I do like to cover when to use attack-driven development, because as much as I would like that this would be a great process in every form of development that exists, that's just simply not true. So for me, I have found it to be really valuable in web application development, specifically because when it comes to HTML5 or CSS3, or even JavaScript, ES5 or ES6, for example, fairly stable. They're not something that's dramatically changing between versions. And as a result of that, you can rely upon the prototypes that you build to be working pretty similarly throughout the process of development. If you learn something in HTML5 today, it's probably still good for the next 3 years. If you learn something in AngularJS or Angular 5, I guess now, it's probably not good. At that point, it's like, okay, maybe 2 years from now, Google will break it. They've got a habit of breaking it. So web applications at a simple level, really, really great from a conceptually simple process of, okay, I just need to write a little bit of code, spin up a browser, I have a web page. Of course, prototyping is quick and easy, and then from there, the information that you need is widely available. W3 Schools, Khan Academy, any number of different Stack Overflow pages that probably also have bad code, but it's going to be good code. It all exists. So it's easily available and something that you can go ahead and look for good examples to pull from and start to work from. To that end, I like to say that the attack-driven development process is very effective, or it's over 9,000. When it comes to greenfield projects, on the other hand, it's really important to go ahead and make sure that your development resources are informed of potential processes that are going to fail as a result of whatever they're developing. And so the foundation of any new product that your company is writing is largely determined by who you have available to write it. If they all happen to know Python, they're not going to write a Ruby on Rails app because you're not hiring Ruby on Rails developers. So, of course, complexity of whatever they're writing is probably simple at first, and we've all seen scope creep, so it never ends simply. And then prototyping from there generally drives the decisions of the business. Are we going to add this feature or not? How much time and effort is it going to take to develop that? And at the end of the day, attack-driven development will help you and your team understand, okay, if we go down this path, here's the extra work that we need to do to secure it. Do we want to do that? And so, of course, most of the time they'll say, well, no, what if we just import this library and then we can go ahead and go that route? Leads to other problems, but at the end of the day, maybe not a bad idea. So again, attack-driven development there is pretty informative. And of course, if you're new, if you're repeating yourself over and over and over again, you're kind of compiling that knowledge, and over time, you're going to start to realize that, okay, actually, I can speak with some authority on this because I've actually tested this enough times to understand how this works, why it breaks, and then how to fix it. Most of the time, and especially for me when I was new getting into this, I would have debates with people, and then I would learn something new, and then I'd go back and I'd test it, and I'd find out actually they were wrong because I know why this breaks because I've actually attacked it. And until you actually sit down and write some code and attack an application, everything you're learning is theoretical. It's kind of like everybody has a plan until you get punched in the face. Well, everybody writes a great web app until they punch it in the face. And then suddenly they realize maybe not a great web app. So again, when it comes to experience and being able to develop knowledge over time, definitely check out or process through writing code, because you can read 1 million blogs and listen to 1,000 podcasts, but until you put your hands on the keyboard and actually do it, it's all just theoretical. So, of course, there are times when you really don't want to use attack-driven development because, let's face it, again, it doesn't work everywhere, and there are just certain things that it won't work on. A great example of that is, of course, compiled languages. So to that end, if you have GCC versus Clang, and you compile this little bit of code, which is just an int main x equals 0, return x plus 1, or x equals 1 plus x equals 2. Sometimes it's 3, sometimes it's 4. Depends on which compiler you use. So if you've got undefined behavior in the development stack that you're writing in, maybe that vulnerable code you've written isn't really vulnerable. It's just the compiler that you wrote that you used to actually go ahead and put that together. So to that end, it's kind of like, okay, if I'm learning this thing and I want to make sure that I'm attacking it correctly, I probably already need to have deep knowledge of the language to really understand how those edge cases fall out. And again, if you already have deep knowledge, you probably already know about the security problems, and that's not the point of attack-driven development. It's to take something new and build that knowledge quickly, iteratively, and kind of holistically, or with a broad focus at times. So to that end, of course, if you're also prototyping, it's kind of be difficult because you never know if you're writing it on a Mac and then suddenly you go to compile it on a Linux server and it doesn't compile the same way. It's going to cause problems, it's going to be a headache, and it's not going to be effective for you. So to that end, attack-driven development as a process, build it badly, break it, fix it, keep going, not really useful, or at least only tangentially useful. Of course, if you lack practical examples as well, as in the case here with John Rosner, excuse me, he was talking about, in this case, Rust, of all things. And because a stack is under development, your complexity is potentially infinite. And the reason that is because especially like if you go out and you try to learn Angular, go out and Google how to do something in Angular, and you will get how to do it in AngularJS, how to do it in Angular 2, which, by the way, it uses like TypeScript. It doesn't even use JavaScript anymore. And it's like, try to do it in like 5 or 4, like breaking changes everywhere. And so to that end, complexity of your app and your examples, good luck. Like, you're probably going to start writing one way, and then suddenly someone's like, oh no, you got to do it this entirely other way, and you got to backtrack and keep going again. So to that end, prototyping here, assembling anything with, from IKEA without instructions, good luck. You don't know what it looks like, you don't know what it should look like, you don't know how it's supposed to work when you're done. And if you manage to get there, great, but again, it's a headache, it's a slow process. You're probably learning a lot, but you're learning it slowly, and the point of attack-driven development is to learn things quickly. So again, tread carefully. Finally, if it's incomplete, if the language that you're working in is like you're running nightlies to kind of keep going, as was the case with Docker for a long time, especially Docker for Mac, where you're getting constant updates and things are breaking, everything that you're learning and everything that you're writing from that perspective is out of date. So you're only getting some tangential benefit from the tools like Burp or like Zap or what have you. If you're using other things around that given framework or library, you're going to learn a lot about those. But at the end of the day, all of your things that you're writing as prototypes or examples to attack, that knowledge isn't going to serve you very well in the next 10 days or the next year, because somebody's going to have moved on and the company's suddenly going to be developing something different. And all that knowledge of, oh yeah, I can break this, this is fine, I'm a security engineer, I can totally hack this. Probably not true, because everything has since changed when you last looked at it. So again, that knowledge that you gain is going to be short-lived. So if this process, or this whole idea of attack-driven development, building things badly, quickly, breaking them, fixing them, keeping moving through that process of interest to you, it's really important that you build an important and an effective lab. If you hate working in your lab, you will not work in it. Pretty simple, right? So you gotta like the tools that you work in, you gotta like the operating system you're running, you gotta like the laptop or the monitors that you have, because if you don't have something that you're actually gonna use at the end of the day, you're just never gonna use it. So for me, if you're running things locally, I really very, very highly recommend checking out Node.js. It is the underpinnings of every, like React.js, AngularJS, everything that you're seeing in a .js world today is underpinned by Node.js. And to that end, you're probably already seeing it in your environment. And if you're not seeing it in your environment today, you probably will be soon. The way that I like to think of it is it's very similar to Python environment variables or Python environments that you run, but you can have directories that hold all of your given project-specific packages in that folder, and I can just go in, node start, I've got an app running, I'm good. Really great for testing different libraries that you've imported as well. If your developers are like, oh yeah, we can just import this library and we're good. Import it, check it, test it, plug in the code. So in addition to that, definitely check out Docker. If you haven't, it's probably already in use today in your environment. And it's, for those of you that don't know what Docker is, it's essentially micro-virtualization for small, simple applications that you can develop that you can go ahead and spin up quickly, replicate across different environments. It's a little wonky on Windows versus Linux and Mac, because if you're on Mac or Linux, anything that you've compiled as an image and you're running is going to be pretty much the same. When I was training at DerbyCon, we had several students who were having difficulties with Docker Compose, for example. And if you've ever worked with Docker and you've used Docker Compose, it's basically a manifest of how you're going to build up a series of microservices to all interact with one another. Really awesome tool. And again, if it doesn't work on different systems, maybe you can't share it, but at least you're still building that knowledge locally. And you don't need to have any internet access as long as you've already pulled things down before you're on the plane or you've traveled. There's also Vagrant. So again, not really seen in the enterprise today. It is something that it's kind of like if I'm going to run a server and I need to build all of the deployment scripts and the shell scripts, et cetera, to make that server run the way I want it to, Vagrant's going to use those same sort of scripts locally to build up a virtual machine. So useful if you're going to go and provision something later as like a bare metals machine. But for the most part, you're going to find Docker is what's largely adopted by businesses today. So learning it now, especially Community Edition locally for your lab environment, sharing your volume of your source code into the container and running things accordingly is going to be beneficial to you overall. So of course, there are people that really like to put all of their tools in one place. There is, of course, VMware Fusion or VirtualBox. To that end, I generally like to give as much resources as possible to my tools, namely Burp Suite Pro because it's a memory hog. So I tend not to use any sort of virtual machines anymore. I literally use just Docker containers for all of my tooling, up to and including Kali Linux. They actually have a bare bones Kali Linux image that's readily available, and then you can just pull down all the packages into that accordingly, and then start playing with any of the tools that you might use. Then when it comes to editors, personally, I use VS Code. Now, again, I come from a world of using Vim mostly to develop, but if you've not checked out VS Code, do yourself a favor and look at it, because I was very much an opponent of anything Microsoft. I don't run Windows, I don't run even Office 365, any of it. I don't want anything to do with anything from Microsoft, and then I checked out VS Code and I was like, not bad. I could actually use this. This is really good. Very extensible, very powerful, lightweight, fast. It's got just a great IntelliSense as well, so check it out. If you need a full-featured IDE, WebStorm or PyCharm is really good. Anything from JetBrains is generally pretty good, but again, it costs money, whereas VS Code was free. So for me, I was like, okay, $7 a month for WebStorm, not a huge deal, but VS Code ended up being better. And then personally, I do all of my testing from a security standpoint in separate browsers. So as you're seeing, I'm actually using Chrome for this presentation here, but I use Firefox Developer Edition for all of my testing purposes. I like to have an entirely separate testing environment. Now, if you still want to use a Chrome environment in general, there is AutoChrome. It's something that NCC Group put out about 6 months ago now, and it basically has Chromium embedded, or Chromium under the hood, and it just like builds different profiles and allows you to do a lot of separate testing in a really nice and clean way. So if you really want to use Chrome, check it out. There are a lot of plugins that I specifically enjoy in Firefox, and specifically the Developer Edition that I like to use. And if we have time at the end of this, as we probably will because I'm going kind of fast, I'm happy to pull up some of my tools and share what I'm using today as well. So we can do that if we have extra time. Now, I'm sure some of you are probably like, what about the cloud? Can I just do this in the cloud? And it's, yeah, sure. If you like Linux, you got AWS. You can absolutely use this in the cloud if you want to today. If you're a big Microsoft shop, you're probably using Azure. As Have I Been Pwned has proven, Azure is really powerful. Troy Hunt is an MVP at, well, he doesn't work at Microsoft, but he's a Microsoft MVP, uses Azure for all of the Have I Been Pwned stuff, and it's powerful and it's fast. And he is just kind of expounded upon that. And personally, I'm not really big into Windows, again, not really big into Microsoft, so I just haven't checked it out yet. Also, Heroku, which again is something that I didn't use until I actually came to BugCrowd, because it's a kind of an interesting cloud-like environment similar to DigitalOcean for you, those of you that have any experience there. And it allows you to spin up quick projects or tooling and then just kind of run with it and then spin it back down. Now, at BugCrowd, we actually have used this internally for kind of like group projects or group fun. So every Friday we have hack time from 12 to 4 East, and we literally just spend time hacking on things. Sometimes it's bug bounty programs, sometimes it's a WASP juice shop, and we literally will just spin up a Heroku juice shop instance and hack at it. It's just a fun time in general, and it's an interesting new way to do things on the cloud. Now, with that being said, of course, cost, maybe free, maybe just a pittance, maybe a lot, depending on if you accidentally leave that thing running for a long time. With that being said, of course, that's probably not the biggest issue here. The biggest issue is legality. If you're doing any sort of penetration testing in the cloud, especially on Amazon, you generally need to fill out a form that says, I'm having the following approved penetration testing company perform security testing against my cloud instance. That's my own VPC that I own. Even if you have written a bad web application that you are now attacking on purpose, you probably still need some sort of legal permission to go ahead and test against Amazon's web services. So, to that end, legality, I don't know. I'm not a lawyer. Very questionable at the least. The most friendly that I can tell is Heroku when it comes to that, but as I said, why would you want to do it in the cloud, right? You could run into interference. Maybe they're using Akamai. Maybe they're using Cloudflare. Maybe they've got a WAF that stands up in front of all of their web development presences and their VPCs. If you're using the free tier, that's probably not the case, but it could be. You could have written purposefully bad code that is vulnerable to a very complex, maybe remote code execution or what have you, and it might not work. And if it doesn't work, it's not because maybe you learned to write it badly or your attack just isn't working appropriately. Maybe it's something between you and that cloud instance that isn't working right. So to that end, my recommendation is don't. You can run it all locally, whether it's Node or Docker or even Vagrant. And you have a lot of options to run it on your own system or even on like maybe a local server if you have like an extra gaming desktop in your household that you haven't used in months, like me. You can just kind of all run it internally, and it works pretty well. So I don't really see the reason to use the cloud other than because you want to learn how to use the cloud, which is an entirely different process and fairly complex in general. I mean, how many people here have seen S3 buckets open to the internet with bad data or read reports on it? Or it happens, right? Like people are setting this stuff up badly, and as security folks, we need to learn how to attack that, and also, of course, how to set that up appropriately or securely, right? Again, maybe not attack-driven development sort of mindset here, but probably worth checking out at some point. So from there, I'd like to talk a little bit about who benefits. Like, who really could benefit from this process of attack-driven development, putting their hands on the keyboard, writing some bad code, and attacking it. And the first kind of group of people that I like to point to is security engineers. Let's face it, security engineers today, if you were hired a year ago, you have more responsibilities today than you did when you started. And that's not just because you're new to the company. It's because the company is asking you to do more. You're no longer in charge of the SOC and the firewall and the IDS IPS. You're now in charge of going into agile scrum meetings and giving security advice. You're now in charge of running phishing campaigns. You're now in charge of any number of different things in your environment that you weren't initially signed on to do. And your pay isn't growing with that number of assignments either. Like, let's be real. You probably should be making a lot more than you are making. To that end, if you learn application security, you're going to be incredibly more valuable to your business or to the next company that wants to hire you than you are today. The only way to do that is to get your hands dirty. Because at the end of the day, again, it's all theory until you actually put your hands on the keyboard and start doing this stuff. Of course, there's also developers. I mean, for me, I always like to call those developers that are interested in security as cyber curious. They're kind of interested in the security thing, but they don't know where to get started. Best way to help them is to show them how to build a bad application and then show them how to attack it. I mean, for me, whenever I've seen someone get their first reverse shell, their eyes light up. It's like suddenly they realize, oh, that's why I shouldn't be using that framework or that library or writing it in this way. And then they actually start doing more of it, which is great because for us as security people, there just simply aren't enough of us to go around. So if we can start to deputize developers to actually write more secure code or perform more testing, at least in a little bit of a manual way, because again, tools are going to fail us. At the end of the day, the people that trust that security has been tested are the people that know that it's actually been tested by a human, because you're going to have false positives, you're going to have false negatives, you're going to have edge cases, you're going to have a lack of context. Sure, there's cross-site scripting, but is that an admin user or no? If it is an admin user, maybe they could do a lot worse than cross-site scripting. Why would I care about that? when they're now an admin user, and they shouldn't be. So again, developers being able to test for security in their code is going to give them more value from a perspective of trying to get hired. Of course, they're not needing a new job, probably, because they're getting paid a lot of money already. But they're deploying code to production. DevOps is here to stay. If they're deploying code to production, well, guess what? That code in production is probably something you're going to get yelled at as a security person, even if you never tested it. So we need to get them involved in the security responsibility. Otherwise, we're kind of up a creek without a paddle. And then, of course, students are, in my opinion, especially college students, the individuals that we really need to get involved with this. And for me, my first class was writing Hello World. I'm sure, how many people here have written a Hello World app in a new language that you've, adopted, right? Everyone's written Hello World. It doesn't do anything for you, right? It shows you a little bit of the syntax, but it doesn't actually teach you anything. Now, every civil engineer, people that make roads and bridges and sewage systems and electrical, lines, etc., the first thing that they learn in college on the first day is this. It's the Tacoma Narrows Bridge incident in the late 1930s. The engineers did not account for wind shear when they built the bridge. And it literally created an effect where it got lift. And then, as a result, it would start rocking. And eventually, the bridge collapsed. And to that end, it's if you're an engineer, the first thing you learn on the first day of class is why the things that you're doing, the measurements that you're taking, the materials that you're using, the designs that you're putting together, why that has to be precise, because lives are at stake. Now, how many of you have heard about the Muddy Waters, pacemaker, thing that went on recently as well, right? Developers are writing code that's going into people's bodies. The first thing on the first day of class that they should learn is that the code that they write is people's lives at stake, not just their credit card, not just their social security number, but literally that pump that is injecting some sort of life-saving medicine into their body, that pacemaker that's going in, that IoT device that is heating your home. If those pipes burst, or the house gets too hot, or the fire alarm doesn't work when a fire is going on, that matters in aggregate, and especially to those individuals that are using those devices. So I really think that students could benefit from the first thing you build is a bad application. And then you learn how to attack that bad application, and you know why it's bad. I've written plenty of C programs for classes where I didn't have to do any sort of memory scraping. I didn't have to do anything to say that I was actually, deleting or removing the memory that I was using. And students just didn't care. They just took the doc for points and whatever. I still got a 90. That's really, really bad, and we all know why. And I think that they should know why. So, of course, if you're getting started in this, it always helps to have resources. And there are a few resources that I really like to highlight. The first, of course, is the Web Application Hackers Handbook by David Suttard and Marcus Pinto. It is about 6 years old now for version 2. But again, it is one of those books that even the general processes that it teaches you, the mindset that it teaches you, is still valuable. Sure, the web has changed since then. But again, it's something that I think everyone would benefit from reading if you're looking into web application security, just because of the fact that the processes are still important to walk through. Of course, there's also Pete Jaworski's Web Hacking 101. So Pete actually trained here at Hackfest. So Pete, if you're in the room, thank you, because this book has been right there in the back. Thank you, Pete. Big hand to Pete, you guys. This book takes everything that you read in Web Hacking, or Web Application Hackers Handbook, and makes it real. Right? That's a big difference. When you suddenly realize that, Yahoo or Etsy or Pinterest or what have you, whatever he's highlighted in the book from a different attacks perspective, those actually happen in real applications. And suddenly it's oh, this stuff that I'm learning isn't just theoretical anymore. And it's actually worth money from a bug bounty perspective. So a little bit of self-serving. I work for BugCrowd. We're a bug bounty company. But with that being said, I think that when you're looking for practical applications or practical examples of the things that you're trying to build and break, it's a great book to reference. Of course, there's also Andy Gill's Breaking into Information Security. If you're new to this, if you're still a college student, or even if you just kind of want to move a little bit more into the AppSec space, he has a really great book. And both Pete and Andy's books are on LeanPub, so they're ebooks. But it goes through building a resume, things to think about, different areas of security to work through, and different tools, etc. It's just generally a good book. One that I more recently picked up and I'm still working through, but again, Andy has written a great book here. Now, of course, I also like to listen to podcasts, and so I'm a really big fan of Application Security Podcast by Chris Romeo and Robert Hurlbut. They talk about a lot of different interesting things that are going on in the application security space, whether it's Docker containers with Jay Beal. They actually just did another Docker container one more recently with someone that works for the United States federal government, talking about Docker security as something that they're testing. So it's just a generally good book to stay, or excuse me, good podcast to stay up to date on different things that are happening in the AppSec space. They actually just did another one on the next version of the OWASP Top 10 as well. So check that out. Of course, there's also Timothy D. Block's Exploring Information Security podcast. This is going to go beyond just AppSec. It'll give you like things like DFIR or how to make good use of time at a conference. It's literally everything across the board. And he does a ton of different ones where he interviews a lot of other people in the space as well, and he does some one-offs. So check that out. Johnny Christmas has been on it a few times, so it's just a good podcast. Now, if you're into coding or you need to get into coding because you don't know how to do any of that, check out Coding Blocks, because for me, they've covered a lot of different things that I haven't seen before or perhaps even new. So, for example, anti-patterns. I was like, anti-patterns? What is this? Like, I know what patterns are and like how to develop certain things, but what's an anti-pattern? They're a long format podcast, but again, if you're looking to just get a little bit on the development side, because everything you read and you hear is a security standpoint, it'll be informative to you. And then, of course, there's Software Engineering Radio. Again, they just do interviews, but it's interviews of people doing interesting things with interesting technologies. So worth picking up on the side. And then, of course, websites. So we're all at a computer all day, so we're probably reading through these. If you need documentation on just about any different language or framework or library or even tools, check out devdocs.io. I actually used that when I was flying out to San Francisco for work. It was about a 6.5-hour flight. I was building this slide deck like several months ago. And to get all the CSS that I wanted and the JavaScript that I needed, I used that site. And it allows you to actually cache the documentation to your browser, so you can use it offline. It was really, really useful, and it covers things from GCC to Docker to any given .js. It's even got some database stuff in there. It's pretty awesome. There's also, of course, the Docker docs, doc.docker.com, or docs.docker.com. And for that, what I really like about it in general is if you're learning Docker, at the very top of the article in italics, just under the article's title, it tells you how long it will take you to read that given section, which for me, it's like, cool, if I'm going to invest 5 minutes, I know that this will take me about 5 minutes. Or if this is going to take me 20, I don't have time for this. So again, check it out, read it, learn how to use that as a tool. Node.js speaks for itself. Then, I'm sure as many of you have probably already used Portswigger's website, portswigger.net, makers of Burp Suite Pro. A lot of really useful information, articles. We actually referenced them in the DerbyCon training that I gave for getting reverse shell or remote code execution later into reverse shell off of different versions of Angular because of the AngularJS sandbox. And it was sandbox escapes because the sandbox was never intended to be used as a security tool. Developers are like, sandbox, cool, don't have to worry about this, security tool. And it gives you like each different version of code that you could put in to get remote code execution. And then eventually Google said, you know what, screw this sandbox thing, deprecated, we're not going to fix it anymore, we're just removing it entirely. And then you just go right back to the top again, and that same first snippet of code in the first version of AngularJS will still get you remote code execution. It's like, yeah, because the developers didn't care to test any of the stuff that they were building. Tim Tomes, or Landmaster53, used to work at Invisium, is now a freelance or a solo security consultant running his own business, gives really great trainings. He's actually giving one in February in Boston, put on by OWASP Boston. So from here, if you're driving, that's like 6 or 7 hours. If you're flying, maybe 2 or 3. It's a 3-day training that he gives for a practical web application penetration test, including fixing all the broken things in his code that he has written. I've taken the class, I really liked it. He does some really good research. Also the author of ReconNG, as you guys have probably heard about. So I am also running a website, AttackDriven.io. It doesn't work on mobile right now, it works on your computer, but it just is a silly landing page. So writing in React.js, going to be coming next spring. It's going to be talking a lot about the different languages, libraries, frameworks that I'm focusing on, maybe some starter, simple, broken code that you can work from, and then from there, maybe like different chains of attack, et cetera. So that's going to be forthcoming. So finally, and most importantly, I just want to give thanks to a few people who have made my career and my ability possible. And the first would be my wife here in the front row, who, as a supportive person in my life, basically has been patient with me, has allowed me to go out and do crazy things like this, as well as give trainings and spend time actually learning how to do a lot of this stuff. So big thanks to my wife for actually making this possible. She's also my partner in crime. We do a lot of adventure, so this was actually taken at Disney. We tend to go there a lot, to say the least. Then, of course, there's my good friend, Katie Ledoux. So earlier this year, Katie asked me to give her feedback on her first talk that she gave at B-Side San Fran. She was really nervous and worried about it, asked for some feedback. And before then, I had never given a talk anywhere. And I was like, you know what, this actually is a really cool idea. Maybe I should, like, give a talk. And she has been very just kind of inspirational and supportive of that process. And then my sensei, Jason Haddix, I have learned more from this man in the last 4 months than I think I have learned in the last 4 years. He has given some really great talks in the Level Up conference put on by Bug Crowd this past summer. So if you look up the Bug Hunting Methodology V2, or TBHM-V2, he did an entire talk on that recon at DEF CON. He's just an amazing human being, and he's trained me a ton. So big thanks to him for all the things he's taught. When it comes to further research, if any of this is of interest to you, definitely check out the Build It, Break It, Fix It competition. That's for college and graduate students. I don't know if it's US only. If it is, I apologize. But it is a very cool just kind of concept that actually follows much of what I've talked about here, because you have a team that builds an application and they build certain features for an application. They've got a list of different features and point values. Then you can have either a hybrid team or you can compete as a red team. And you can gain points as the red team by attacking and breaking those features on another team's application. And then the hybrid teams do both. So the whole concept of attack-driven development, of build it badly, break it, fix it, make it more secure, could really be informative for those students, because now I can compete as a hybrid team because I know how to attack things, I know how to build things securely. That way I can get the most points and keep them. There's also the underhanded C contest, which is literally building what looks to be benign code that compiles, and then it actually is malicious. There was one several years ago that was, I think, only like 5 lines of code. And it looked very benign, but when it compiled, it wrote out terabytes of disk space usage and just would lock up your disk. So they have just kind of a really cool concept of write bad code that doesn't look bad, and then try to win on different kind of functionality that is malicious. There's also the getting past the positive. It was like a PDF doc or a white paper that was written by Gary McGraw and the folks at North Carolina State University that goes through the misuse and abuse cases that I talked about earlier. Again, misuse and abuse cases are still useful, they're still beneficial, but I think that we need to test them more regularly. If you want more on BSIM or other stuff that he has done, it's now at synopsys.com with that long link there. And of course, if you need anything on secure SDLC, OS cheat sheet is really good. 7 Phases of SDLC by Microsoft is also really good. With that, I'm happy to show some of my tools, some of the stuff that I'm using from like my browser extensions and stuff. But are there any questions? No? Okay, cool. Are you guys interested in seeing the stuff that, oh, one question. No. Decrypt data in the cache? Honestly, I don't know. Maybe, depending on if you can get access to it. Unfortunately, I don't know. Any other additional questions before I show some of my extensions and tooling? Cool. So I'll just kind of quickly show. Sorry, got to make this not full screen. So from a browser, as I spoke earlier, I like to use Firefox Developer Edition. The biggest reason is what you're seeing here on the left, which is tree-style tabs. So if I go out to like google.com, actually I don't have Wi-Fi on right now, but basically what it will do is it'll open every new tab vertically, and then if it's a nested tab, it'll kind of nest it down a little bit. So if you've ever used Chrome and you've had so many tabs open that you can't read what the tab is, that's why I don't use Chrome for testing, because I will literally open hundreds of tabs at a time to try and figure out web functionality, to force it to go through my proxy and go through Burp Suite Pro to aggregate more data and do more testing. So that's just one that you see kind of readily. So as you're going to also see, some of these are listed as legacy, so they're in the process of being updated because Firefox has changed its extension functionality. So if you go out and you grab Firefox Developer Edition, make sure you bring yourself offline before you install it and turn off auto updates, or a lot of these things break. User Agent Overrider is really good because if you want to actually see what the website looks like from a mobile application perspective, which may have different functionality, different directory path structures, etc., useful to have. Again, that's just something that I like to see visually. React Developer Tools. Oh.
The user agent extension, does it come with a list of user agents?
I believe so, yeah. So you can put them all in right here. So it does come with a list, but you can go ahead and provide additional ones. So I know that some folks on Twitter the other day were talking about how they like to change the user agent to what would provide like it would cause a blind SQL injection in the application. Like you could easily just dump all of those different strings in here and just kind of keep running with it if you wanted to. I like it because it's easily customizable. So Wappalizer, if you haven't used it as well, it's kind of similar to Built With. It kind of just tells you what the application is actually built with. It tells you CMS, if they're using like Google tracking, etc. But it'll also tell you, okay, they're using PHP version, what have you. And sometimes it's really useful because then I can just go look up CVE, PHP, and version number, and just find everything that's broken with it. React Developer Tools is interesting because if you go to an application that is built with React, and it's still the developer version, they're not using like the actual build ready version, it'll pop up in red. And it'll be like, okay, they're using React Developer Edition here for this, and it's like, okay, cool. I know a little bit about that. I've done enough testing with it that I could be like, okay, that at least tells me that maybe their developers aren't doing all of the best practices, and this is actually worth going after from a few different perspectives. Also, open multiple URLs. So that's right here. What I can do, and what I often will do, is I will go into Burp Suite Pro, I will highlight everything, and then I will parse all of that down to top-level domains in most cases, and then I will just start dumping those in and hit open URLs, and it'll just start opening tabs for me, which is great. The other side of this that's really useful is if you ever go to a site and you want to know different pages that it links to, maybe some of them are hidden or what have you, you can just go to look at the source code, copy all of it, paste it in here, and go to extract URLs from text, and it will pull out all of the URLs that are inside of that source code, which is really beneficial because I don't necessarily want to go around and click on every single link on the page to get it to actually populate. Now, of course, Burp will do that automatically for me. It'll continue to spider through things. But sometimes I like to really look at the pages. So also very useful. And I know I'm probably just about out of time. So I guess with that, I just want to say thank you all for coming, and thank you for having me.